Hello viewers, we have been discussing various members of the TCP/IP protocol suite. In the last lecture, we have discussed the protocols in the network layer, the IP, Internet protocols, and then the companion protocols like ARP, RARP, and ICMP, which are used for various purposes which we have discussed in the last lecture. In this lecture, we shall be concentrating on the protocols in the transport layer, TCP and UDP. There are two protocols. One is TCP, Transmission Control Protocol, and another is UDP, User Datagram Protocol. This TCP is connection oriented and reliable protocol. On the other hand, UDP is connectionless, unreliable protocol. Let us first consider the UDP, User Datagram Protocol, which is simpler of the two, and then we shall consider the TCP, which is very rich in its function. The key features of UDP are shown here. As I told, UDP, the User Datagram Protocol, is connectionless. It is unreliable. Unreliable means there is no error control, there is no retransmission, and all these things which are present in your error control for reliable communication are not used in UDP. Then what it really does? It is a thin protocol. That means it adds very little to the IP. IP is also a connectionless, unreliable protocol, and UDP is also connectionless, unreliable protocol. So it adds very little. What it really adds is it provides a simple interface between the application programs and the Internet protocol layer, Internet protocol. And by doing so, it provides a mechanism for communication between application programs on two sides. Essentially, it serves as a multiplexer demultiplexer for sending and receiving IP traffic. To understand why this multiplexing and demultiplexing is necessary, first let us try to understand why two application programs cannot communicate directly using Internet protocol. As you know, the Internet protocol uses a 32-bit address. That address essentially refers to the host. But in a multi-user environment, in a single system, you can have a large number of application programs running simultaneously. So a host, just by telling the host, is not enough to deliver a frame, a datagram to a particular application program. So if two application programs wants to communicate, then we have to develop some scheme by which two applications program can communicate, and that is precisely done by the UDP protocol. To understand it, let us look at the UDP datagram format. The UDP header comprises of 8 octets or bytes or two 32-bit words, and first 16-bit is the UDP source port, and next 16-bit is UDP destination port. So we find that a concept called port has been used. So what is the concept of port? It is an abstract destination point that can be referred to as port number. Or you can look at it in this way. You have got the UDP layer, say here, let's assume you have got a UDP layer here, and UDP provides a number of access points. So the port numbers can be considered essentially as access points to the UDP. And using that port number, you can do multiplexing and demultiplexing. Let us try to understand how this can be done. So let's assume this is the UDP running in one host. Say this is host A. This is host A. And there are a number of applications program running under this. So this is application program 1, 2, 3 and so on. 1, 2, 3. And there is another host in which also you have got UDP protocol running. I am not showing you the other protocols below it. And here also there are a number of application programs running. What is being done in UDP? Each application program is associated with a port number. Now, this association of port numbers can be done in two ways. One is known as universal assignment, that is permanently assigned to a particular application program, and another is dynamic binding. And in this dynamic binding, the application programs are dynamically assigned the port numbers. So one can use one of the two techniques at a time. But in UDP, some kind of hybrid approach is used. So UDP uses a hybrid approach. What does it mean? That means there are some port numbers which are assigned a priori to some well-defined applications. For example, for telnet, for FTP, the various application protocols that we shall be discussing in my next lecture, each of them is assigned a well-known port number. So these are known as well-known port numbers. And the range of well-known port numbers is 1 to 1023. And then, as we have seen, the format of the UDP datagram, this is 16-bit. The port number is 16-bit, both for source port and destination port. And so the remaining numbers starting from 1024 to 65535, these numbers are assigned dynamically to different users. And obviously, with time, this number will vary. So a particular number can be assigned to application program 1, or in the next time, after certain time, the same number can be assigned to another application program. So whenever a number of datagrams arrives here to the UDP, based on that destination port number, it can do multiplexing. It can deliver it to, say, the application program 1, this is 2, 3, 4. So this demultiplexing can be done. And similarly, the one side can send application programs coming from different applications, and the datagrams can be sent by the UDP, and which does some kind of multiplexing. And here I have shown demultiplexing. So the UDP performs multiplexing and demultiplexing so that different, as I said in this, it serves principally as a multiplexer and demultiplexer for sending and receiving IP traffic. And actually it allows you for communication between application programs directly. So this is what is being done by the UDP protocol. Now you may be asking, this source port number, is it always necessary? The answer is no. The source port number may be present or may not be present. Whenever it is not present, it is given the value 0. As you have seen, this 0 is excluded both from well-known port numbers and also from the user port numbers. So 0 is not there. So 0 is assigned when this source port number does not exist. And obviously, when it exists, then the other side can send acknowledgement and various other messages to the source application program, but it may not be present. Then this UDP message length gives you the total length of the UDP datagram in octets. So message length is the length of the UDP datagram. Now, coming to the last header component, that is your UDP checksum. You may be asking, the UDP is a unreliable protocol, connectionless protocol. Why do you need checksum? Checksum is commonly used for detection of errors. Actually, the UDP datagram provides facility for checking errors, but once a datagram is found to be with error, it does not do anything. It is up to the upper layers, application layers, to decide what to do when a datagram is found to be with error. That means it will be the responsibility of the application program to send some error message or something like that, but UDP does not support it. Let's see how the checksum is computed. Checksum is computed with these fields. The first part is known as the pseudo header. This pseudo header, along with the UDP, or this header it can be for UDP or it can be for TCP. So this checksum is valid for both, and then the user data. So you find that the checksum is computed over the header reason for that is the header does not contain information about the source address and destination address, as we have seen. The IP address is not present here, but an application program is uniquely defined by 5 components. So, or you can say that the association between a pair of application is done by 5 tuples. These 5 tuples are the protocol. It can be either UDP or it can be TCP. Whatever transmission layer protocol is being used, that has to be stated. Then the source IP address, then destination IP address, then you have got the source port number, and the destination port number. So these 5 tuples uniquely makes the association between a pair of applications. And obviously, unless all these components are part of the checksum computation, it cannot be ensured that the datagram is delivered to the proper application. That's why in this pseudo header, the source address, destination address, and here the protocol, this, if it is UDP, then this value for this protocol is 17. On the other hand, if it is TCP, then this header is 6. So either 17 or 6 is written to indicate the protocol, then source address, destination address, and as part of the header, as you know, the IP addresses are there. The uh, those source port, sorry, as part of the uh, IP datagram, we already know that source IP address, destination IP address, these are all there. So, but in this UDP header, as we have seen, that this is not present. The source address, source IP address and destination IP address is not present. That's why the source IP address, destination IP address, which are not part of UDP or TCP header, as we shall see later, the TCP header, these are added so that the datagram is delivered or communication can take place without any error between a pair of applications. So we have discussed the UDP protocol, which provides you a unreliable connectionless communication, and but UDP is not sufficient, or the service provided by UDP is not sufficient for many applications where we want reliable communication, and for that purpose we have to go for a TCP communication. Let us see what are the basic features of TCP. The transmission control protocol, or TCP, which is also a uh, network layer protocol, the transport layer protocol, and the key features are: it is connection oriented, as I have repeatedly told; it is stream oriented. We shall explain in detail what do we mean by stream oriented. Then it gives you reliable delivery, and for that purpose it allows you, it does error control. We have earlier discussed various techniques of error control. It also does flow control. We shall discuss how the flow control and error control are performed. And finally, it performs full duplex transmission. Let us first focus on this stream oriented protocol. Stream oriented protocol. What the TCP does, it sends streams of data or streams of data bytes or octets. That means each octet that is being sent by an application program is given a number with the help of 32-bit number. So a sequence number is given which is of 32-bit, and that sequence number is given to a stream of data that is coming from the application programs. Let's assume this is the stream of data that is coming from the application program, starting with 0 and it goes up to 2 to the power 32 minus 1. Then what the TCP does, this stream of data is divided into segments. So it is divided into segments, and with the help of, let us explain with the help of the TCP header how this. Let us look at the TCP header to find out how this is being done. Here we have seen this source port and destination port numbers. The function of the source port and destination port number is same as the UDP. So here also the TCP can do multiplexing and demultiplexing and can establish communication between two application programs with the help of these source port and destination port numbers. And here is the sequence number that is being used for giving the the first octet of the data that is being sent here. So here is the first octet. That at the first octet number That sequence number is given in this header. And this, you may be asking, what is the size of the data? So this acknowledgement number is the size of the sequence number is gives the 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 size of the first octet. What about the size? The size of the segment is decided between the two application programs, and accordingly they are given the numbers. For example, say you are sending, let's assume the segment size is 600 bytes. So if the sequence number is 1000, then the last byte in the sequence will be 1599. So the next sequence number will be 1600. So this is how this sequence number is given depending on the size of the segment. So, and what about the acknowledgement number? To understand what is being done by the acknowledgement number, let us see how the data transfer is being done. So here you have got your sender, and here is a receiver, and the TCP performs flow control by sliding window protocol. Sliding window, and that window size is given here. So there is a 16-bit window size, and that is given as part of the header. So here we see the sequence number is 0, 2 kilobytes of data has been written by some application program, and that has to be sent to the receiver. So with sequence number 0 and size of the data is 2K, a 2K data is being sent to the other side. And after receiving this, the receiver sends an acknowledgement with SEK is equal to 2048. So here we find that it has received up to sequence number 2047 since it is 2K. So it is now waiting for the sequence number 2048. And it also says the window size is 2048. The reason for that is initially the buffer in the receiving side was 4K. Now it has already received 2K, so another 2K is available, and that's why the window side is set here to be 2048. And this 2048 window size is being used, and after this is being received, suppose another 3K has been written by the same application program, then another it was 0, now it is written 2048 because up to 2047 has been sent and acknowledgement was received for 2048. This means that the receiving side is waiting for acknowledgement, waiting for the sequence number 2048, and the size of the segment is 2K, and after receiving this the buffer is now full. So it sends an acknowledgement, the receiver sends an acknowledgement with SEK is equal to 4096, that means it is waiting for the sequence number 4096, but 4096, but window length is 0. So we see that now the buffer is full and the sender cannot send another data unless it receives acknowledgement knowing that the window is free. So window has been extended. So after half of the data is read, here half of the data has been read, and so this becomes empty, and this is actually at this point. So it sends an acknowledgement with window size is equal to 2048. That means another 2048 bytes can be received by the receiver. So it's after receiving this, it sends the remaining data. So 2K plus 3K, 5K. Already it has sent 2K plus 2K. So another 1K is sent here. Although the receiver is ready to receive 2K as it is shown here, it sends only 1K because it has got only 1K of data, and after receiving this, this 1K is filled up and 1K remains free here. So this is how the sliding window protocol works, and the acknowledgement that is being sent by the other side is being done in a piggybacked manner. Piggybacked manner. While discussing the sliding window protocol, I have told that the acknowledgement can be sent by sending a separate frame or segment from the other side, or it can be sent along with the data that is being sent by the receiver side, because it is a full duplex communication. Since the receiver is also sending data, so along with that data the acknowledgement can be sent, and that is what is being done with the help of this window. So we have seen that the data transfer takes place by using flow control, and window size is decided by the receiver side, which is communicated while sending the acknowledgement to the sender. So these two, acknowledgement number and window size, comes as a from the receiving side as a piggybacked information in the form of piggyback, using the piggybacking technique. Let us focus on the next component. This data offset is essentially size of the header, length of the header. This part is optional. So minimum length is 1, 2, 3, 4, 5. So 5 words or 40 octets. So minimum value that is written here is 5. It can be more than 5 because of options given here. Now the function of the checksum is same as I explained for UDP. There, as I told, the checksum is computed along with a pseudo header, and in case of a TCP, you have to use the TCP header with the protocol field equal to 6, and the checksum is performed by using, actually I did not mention about how the checksum is computed. Checksum is computed by dividing the entire data into 16-bit words and then performing one. So once complement addition takes place, for starting with this, these are all added, the 16 by dividing into 16 bits, and then whatever is the remainder, that is used as checksum. And this checksum, once that error is found, then a no acknowledgement is sent to the other side. That means after receiving some datagram, if it is found that there is error, the TCP sends what is called go back N ARQ. So it uses TCP uses go back N ARQ technique. Suppose this is the stream of data that is coming, which has been divided into several segments, a number of segments, and this has been sent, 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 already sent. Actually, it can be represented with the help of 3 pointers. Suppose this is the window. This pointer tells you the segments which have already been sent and acknowledgement has been received. And this pointer, let's assume, tells you these segments have been sent but no acknowledgement have been received. And these are the segments which can be sent before receiving immediately without receiving any acknowledgement. So using these 3 pointers, this pointer is essentially this acknowledgement number. This acknowledgement number tells you up to this number, this is the number which is being given as the acknowledgement number. So up to this it has been received and acknowledged by the receiver. and this is the window size is given by this. This is the window size. So acknowledgement number plus the window size is this pointer, and this pointer points to different segments that is being sent. That is actually comes from the sequence number that is being sent by the sender. Now let's assume that this particular uh, segment has been received by the receiver, and after performing checksum it is found that it is corrupted. That means checksum is not matching. In that case, the starting with this acknowledgement number, again this sequence number data has to be retransmitted. So it goes back to this particular segment number. So we find that here the sequence number is communicated, not really in terms of segments, but this particular sequence number, which is the beginning of this segment, is communicated how various functions which are necessary for reliable communication is performed with the help of TCP. Thank you.